Hello to our dear viewers. We're about to begin the panel component of Mining Journal and Mining Magazine's 2021 Tailings Program. Before this discussion, we dug into an updated version of the Global Tailings Portal, which was kindly provided to us by Professor Elaine Baker of the University of Sydney, and Grid Arendal, which is a Norwegian nonprofit specializing in environmental data. This panel will be a technical discussion around that data. Today we have an all North American panel. They include Matt Trinan, who's Director at Patterson & Cook, a global engineering group specializing in the design and implementation of slurry systems to the mining industry. Matt's joining us from Denver, Colorado. Hi, Matt.
Hello, everybody.
We have Christian Levesque, Manager of Research at Measurand. Measurand joined RST Instruments in 2019 to create a platform of geotechnical companies specializing in integrated monitoring solutions for mines, tailing dams, and other critical structures. And Christian's joining us from the province of New Brunswick on Canada's Atlantic coast. Hi, Christian.
Hi.
And finally, Todd Wisdom, Director of Tailings at FL Schmidt, a Danish multinational engineering company serving both the global mining and cement industries. And Todd's based in Salt Lake City, Utah. Hi, Todd.
Hey, everyone.
So the first question is, from your discussions with operators of tailings storage facilities around the globe, what are the main challenges facing them today? And also, to what extent, if any, have they shifted their focus or the challenges arisen or shifted in relation to implementation of the recent global industry standard on tailings, which was released last year? Matt, why don't we start with you for this question?
Yeah, I mean, I think really the key focus of operators that we've seen is really trying to have a clear understanding of the risk of their operations, and that goes from operating day-to-day operational risk and what they need to do to manage that in terms of ensuring that they're providing tailings that are on specification and meet the requirements for the tailings storage facility, and what implications changing the grind size or the upstream properties might have on the overall tailings operation. And so it's really a matter of understanding the risk involved, and then taking sort of a broader picture is then, we've seen a huge focus on looking at dam breach analyses and run out distances to really quantify if something were to happen, what would the consequences be. In terms of looking at the global tailings standard, we have certainly seen a lot of interest in implementing a lot of those best practices in terms of corporate tailings teams and independent review. And historically, it was primarily independent review was a geotech discipline, and we've seen a lot of involvement now of bringing the upstream process and tailings handling into that review to understand the consequences and implications of changes upstream might have on the tailings facility.
In terms of my company, we work mostly in instrumentation, so obviously the focus has been really towards that side of things. But what we have seen a lot of is people trying to concentrate more on things like automation, making sure that they're certain of what they're getting out of their instruments, that it's easy to understand. Also a lot of demand for trying to get everything brought into one central place that can be easily analyzed. So something that is both good for the engineers, but also for the people that are actually trying to make the day-to-day decisions as they're running things, making sure that they understand how things are responding, and understanding whether or not that's within the expected behaviors for that structure and things of the sort. So really what we've been seeing is a lot of people trying to push the safety side of things and really the lowering their risk by being able to make sure that everything's following within that particular expected behavior, really. So it's been mostly that kind of a push.
Challenges you've been hearing from operators?
Yeah, that's the challenges have been mostly about trying to get that information in one place. That's what we've been finding, a lot of turnkey, people wanting to have a turnkey solution, trying to make sure that they don't have to go someplace necessarily on the net to try to get that information. So it has to be kind of concentrated in that area as well. So that's really the other one that we've been hearing as well. So those two kinds of things, trying to make sure that they understand what's going on through proper instrumentation and ease of understanding what the data means, and the being able to concentrate it all in one spot. Yeah.
Your thoughts?
Yeah, sure. To follow on with what Matt said, we're definitely seeing an increased focus on the quality of tailings and how they're produced. I think that one of the things miners are really starting to think about is they have to think of their tailings more as a product and not as just a throwaway stream, and they can throw anything in there that they want. The more consistent your tailings are, the better you're going to be able to deal with them, and the more accurately and reliably you're going to be able to produce something that's stable out at the TSF. The other thing I would say is that operators are definitely looking at how do they decrease the amount of water that's associated with their tailings. Water is really the issue when it comes to tailings. If you get rid of the water, you really get rid of the issues. So they're looking at a large variety of different dewatering technologies, everything from traditional thickeners up to paste thickeners, centrifuges, belt presses, vacuum filters, pressure filters. Anything that might get rid of some of that water that might be causing them a problem, which is something that FLSmidth provides to the industry, is that we can look at all those different solutions. And then the other thing they're looking at is after they dewater this material to a higher state than it maybe has been in the past, they're looking at how do they transport it and place it out at their tailings storage facility. And that ranges from centrifugal pumps to positive displacement pumps to some types of conveyors and stackers, or maybe even using trucks to do it. So they're looking at all those different solutions on how do they reduce the water and increase the safety of their tailings storage facility.
So I mentioned that we went through the database, the database put together, the Global Tailings Portal, which is a database of around 1,800 tailings facilities. It was based on disclosures and responses from, I think, 98 companies, 98 operators of tailings facilities. So it gives a good cross-section. And the number one factor associated with, a couple of you talked about risks. So the number one factor associated with high-risk facilities, I guess those that were defined as high or very high or extreme, was that they were active. That's not to say that inactive did also feature amongst high risk, but it seemed like the number one factor, the number one predictor that something was high risk was that they were active. Just to give those numbers, active TSFs, or tailing storage facilities, account for 42% of all the entries in the portal, but they make up 63% of the facilities with extreme risk and about 52% of TSFs with any sort of significant risk. That's the high to extreme. And obviously with mine production expected to keep increasing well into the future, especially the demand we're seeing now for many minerals and metals, this will mean more active TSFs. So with that in mind, what are the main things specifically that operators specifically of active facilities should be looking at in order to mitigate risk? And Todd, we'll start with you for this question.
Yeah, so you bring up a good point that there are a lot of active TSFs, and those are the ones that potentially have some higher risks associated with them. I think it's also important to realize that there will be an increasing number of tailings storage facilities out there in the world in the near future. Ore grades are declining while at the same time demand for metals is increasing. That means you have to process more ore and generate more tailings and use more water to get the same amount of metals. So if you increase the amount of metals, you can understand that that increases even more than that. So it's really an issue that they need to be looking at. Safety, as we've already kind of said, kind of revolves around the water in the tailings. There are ways to manage that water by dewatering it early before it gets out to the TSF. But you're also able to manage it at the TSF. And so keeping that water, if there is any water, if you haven't dewatered it, away from the edge of the dam is something that's really important. So they're looking at ways of placing that material after it's dewatered, hopefully further keeping that water pool away from the edge so that if there is potentially some type of a failure, that water doesn't spill out and then create damage, economic and ecological downstream. They're looking at monitoring of that water pool to keep it away from the edge. So I would say it's really about water management is the whole issue that this revolves around for the safety of active dams, but also inactive dams.
In our case, we're looking at it more from a how can you use your monitoring plans in terms of basically better managing your site. So if you better understand what's going on in terms of your placement rates and how the dewatering is acting, you're going to have a better chance of being able to manage that risk and decide, is it time to build maybe another structure rather than trying to continue on this particular one. Maybe it's something that we have to consider, or maybe it's about changing the design. But being able to actually take the information that you're getting, if you're able to actually get it easily and understand it quickly, then that helps you with being able to get your ducks in a row for how you're going to manage the increased rates that we're seeing right now. As we said, there's going to be a lot more water. You have to be able to make sure that whatever's behaving there, that when you're doing your design, it's actually going to be able to handle it the way that you think it will. So understanding that, trying to kind of plan out what would happen if it doesn't work as well. What's my next step? Being able to do that is really the thing that we would probably recommend to people trying to mitigate active sites.
Yeah, your thoughts on active TSFs?
My thoughts on this are hand in hand with Todd, that it really comes down to the water in the TSF. And if you can actively manage that water and get that water out of the TSF, that's best for the TSF operation. You know, there's certainly numerous sites out there that use the TSF as an active water storage facility for runoff collection and you know, just annual water needs, collect water during the rainy season and use it throughout the dry season. And if there may not be a lot of interest from operators because that's a convenient place to put it, but if you can put that water somewhere else, you know, maybe in a potentially a water retaining dam structure, and get it out of the tailings facility, you know, you reduce the risk of the tailings. So certainly, you know, just another aspect of water management. You know, tailings deposition control and maintaining that pond away from the dam certainly goes a long way to managing the risk associated with the active facilities. And I would also say, you know, touching on Christiane's point of monitoring the facility, that and going back to the first question is, you know, you really, operators of these facilities really need to know what the data means. And so, as Christiane said, of centralizing that data into, say, a common dashboard and having indicators of what does this level mean? What is the consequence of this? I think is vitally important to monitoring active facilities. So, and the only other thing I wanted to touch on is that, you know, just because there's more risk associated with active facilities, we can't forget about the closed facilities. You know, the active facilities have the advantage of they're actively monitored. There's people there, and you know, closed facilities need as much duty of care to ensure they're safe, because a lot of those engineering controls in active facilities may not be present in closed facilities.
Yeah, that's a good point, Matt. You know, the Brumadinho failure in Brazil was a closed facility, and it actually, for whatever reason, you can read the report that's out there. Even though it was closed, it had enough water associated behind the dam that when there was the right conditions, it failed, and it was the most catastrophic in terms of human life failure that there's been in a long time.
Second, going back to the Global Tailings Portal, and I should say that our findings, we'll discuss them in more detail in a white paper, which will be released as part of this, part of Mining Journal and Mining Magazine's 2021 Tailings Program. just to give a preview of that, the next biggest factors associated with risk were size and height. The larger and taller the facility, particularly larger, the more, in terms of capacity, the more likely it is to be categorized as high risk. So my question is, because it's sort of that chicken and egg scenario, are big tailings facilities at risk simply because they are big, and obviously the consequences will be much more disastrous in the event of a failure? Or are there actually other causes, ultimate causes at play here, such as, and obviously you've touched on some of these solutions already, like dry and filtered tailings that I think are generally associated more with, correct me if I'm wrong, but generally associated more with smaller tailings facilities. So is it a case of simply big is more risky, or is there more to it? Is it that certain solutions that possibly mitigate the risk can't be applied or as easily or as affordably to bigger facilities? And just to make it a two-part question, what else can operators of large tailing facilities in particular be doing to mitigate risk? Christian, why don't we start with you for this?
So I thought about this a little bit because obviously we deal with different sizes. The largest kinds of facilities that we've dealt with are fairly substantial, very easily visible from space kind of situation. And every time I've looked at these, the one thing they have in common is that water is a lot harder to control. You have a lot more water, and it's not just the size, it's how wet. So when you're talking about this, it's going to be more likely that you're going to have a flow if there is a breach. So as soon as you get a flow, it's going to go a long distance. You're going to be able to carry tailings bar. So it's not so much of a necessarily that large TSFs are necessarily less safe. It's more of the fact that what they're impounding is really much more difficult, and you have a larger quantity. So when you think about what risk is, it's not only the chance that we're going to have a breach, but how big of an area could be impacted by that. So to me, the biggest issue is really the fact that you put all these things together and you end up increasing your risk. And for us, in terms of when we were looking at it, more of how would you try to limit that? Ultimately, it came down to trying to figure out if there's any ways that you can try to do these other dewatering methodologies. It's harder to do, obviously. And then it's a question of how do you help with reducing risk? Well, here you start talking about mitigation, such as trying to come up with alarm levels where this would be something that you could potentially trigger in case that there's a need to evacuate an area. What's the levels that you would want to have so that it gives people plenty of time to get out of the way, so that you can make sure that any fixes that you would have would be put in place before a real important breach would happen. So it's kind of a tough place to be at because you are in a much larger consequence, but you can start trying to think about how can you use the tools that you have in place to reduce that by giving you that chance to understand what's happening and plan out. One of the things that was interesting about the standard that came out is how much they actually pushed towards that performance, but also the planning of how you're going to do the risk and how you're going to mitigate in case there is a consequence. And I think that part there is the key, is really making that decision of how are you going to deal with maybe a minor incident so that you can avoid that larger incident going down the line.
It's quite an interesting question because if you think just in terms of risk, it's sort of the probability of or potential of the failure and the consequence of the failure. Certainly, by having a larger volume or mass of tailings sitting there, you're inherently at higher risk. The flip side of the coin is of course the consequence, and you can think of an example of a small, poorly managed TSF in a highly populated area that would have higher risk than, say, a large facility out in a remote area. But I would say I would think, yeah, by just the nature of a larger facility does bring more risk, both in terms of volume of tailings and quite often the height, giving more potential for runout and things like that. I think in terms of one of the benefits of large facilities, though, is that they are much more tend to be more actively managed and monitored than smaller facilities. So that is an advantage, I would say, in some cases, or not an advantage, but a mitigation of that risk. In terms of what can operators do to minimize the risk of large facilities, certainly, I think Todd will touch on it, is of looking at new technology of the scaling up of filtered tailings, for example, is becoming more and more of a reality. But if we think of other options of these large facilities, we've seen instances where operators, instead of placing the TSF relatively close to the mill where it's sort of easy to get to, that they're looking at locations farther away and transporting the tailings farther distances to areas that would be lower risk and maybe more suitable for a large facility. So there's options such as that as well.
It's a great database, the portal, but one thing that might distort a little bit towards covering more large facilities is that it tends to be larger companies reporting. It also excludes companies from a couple of countries. There's a lack of reporting from China and India, and to an extent from Chile, actually. But also, I forget the exact figure, but the top 10 in terms of the number of tailings facilities also accounted for, it was something like 40 or 50%. No, it wasn't 50. It was close to 50% anyway of all the facilities, and obviously they tend to have larger facilities as well. So something to keep in mind as well. And with that, Todd, what are your thoughts on large facilities?
Large facilities are really, and any tailings facility is kind of governed by what the local parameters are. And what do I mean by that? Well, the first thing you look at is, what kind of a mine is it? Is it a high-grade underground mine? If it's a high-grade underground mine, they don't make a lot of tailings, but they do make some. But where you tend to see these big structures is a large open pit above ground mines. And the reason they're big tonnage usually is because it's a low grade. That means you don't have a whole lot of dollars per ton to spend on your tailings. So they're traditionally looking for what's the least expensive way I can deal with them. So that drives them not to do some of the dewatered tailings, the higher performance stuff like paste thickening or filtered tailings, as Matt said, and drives them to look at slurry deposition. And because there's a lot of tonnage, they tend to be big structures. And when you look at where those facilities are placed, a flat ground might lead itself to be more easily implementing a filtered tailings solution. But a lot of these mines, especially in Chile and Peru, are in mountainous areas, and valleys are or can be or are difficult to place filtered tailings in, especially at large tonnages. So you really have to look at all of those constraints, because if it doesn't make economic sense, it won't be implemented. The mine either won't be built or they won't implement the solution. I think the one change to that has been Brazil, which after their recent accidents, they've mandated they're going to do filtered tailings. And you've also seen the price of iron ore and other commodities go up, that maybe now they can support some of those higher performance solutions. And then on the vendor side, you've seen us develop much larger pieces of equipment that will help them dewater their tailings at a more efficient manner, so that it's much more competitive with a slurry type of a deposition. So I think each mine has to take all of that into consideration when they're developing a solution. Now, if you look at existing facilities that are already there that might have been developed 20 years ago before some of this new technology, new bigger filters, for example, have been developed, they might be reaching the end of their initial mine life, their initial tailings starting to fill up. They need some extra capacity. One of the things any miner can do, whether it's big or small, is to say, I'm going to do a partial filtered solution. So instead of filtering 100,000 tons a day, maybe they filter 20,000 tons a day and start with that to gain some extra time and some extra capacity. And maybe they do half of it. Maybe it's 50,000 tons per day. But that's something that miners are really starting to look at, is it doesn't have to be an all or nothing solution. It can be a partial solution which gives them more time to figure out what to do long term.
We've just started seeing recently, or and that you expect to see more and more of?
I would say it's been kind of a recent development, and we'll start to see more and more of it, especially as these miners start to reach capacity of their current TSFs. They either can't get permitted a new wet impoundment, or it's difficult to get it permitted. So they're looking at, well, if I have 2 years left, can I stretch it to 3 or 4 years and do a partial solution? And maybe then I'll be comfortable with the filtered tailings solution. And at the end of 4 or 5 years, I can do a full filtered tailings solution, because they'll know how to operate it and how to run it, because most big mines don't have that available, that operating expertise to them currently.
The other major risk factor identified in the portal, and it's one that probably many people might have guessed would be the first, was raise type. So obviously upstream has a reputation for being higher risk. It is disproportionately associated with high risk facilities, but not to the same extent as might have been expected. Again, this is from a sample of 1,800 facilities. We know that the ICMM standard doesn't exclude any raise types, although certain jurisdictions do ban new upstream dams. You mentioned Brazil, Todd. They banned upstream raises following the Brumadinho disaster in 2019. Chile, which obviously has a lot of seismic risk, has banned it for, I don't know if anyone knows off the top of their head, but it's been for quite a while. Also looking at other jurisdictions, some of the bigger jurisdictions in terms of numbers of tailings facilities, it notably went out of fashion a long time ago, upstream that is, went out of fashion a long time ago in the US and Canada. Around the 70s and 80s, there's a noticeable just drop off in their use. It still gets used occasionally in Australia, although there looks to be a change probably in the last 10 years towards other types. And it does remain the most popular raise type in some jurisdictions. The most obvious is South Africa. It's a clear number one. It remains a clear number one today. So with that in mind, how important is raise type? Are there situations where it's okay to have an upstream or centerline dam? Didn't mention centerline dams as well, obviously the intermediate solution, or to go for whatever involves the least cost and complexity. And assuming the operator picks the certain raise type based on whatever factors, how can technology play a role in making these raise types safer? Matt, your thoughts?
Yeah, I mean, certainly the dam construction will be highly dependent on the location and topography of where the facility is going to be located. And I would hesitate to just outright ban one particular type. I think they all have their places and uses. And it kind of goes back to what we talked about earlier on, is that with any type of tailings storage facility is going to require diligent monitoring and active care and management for safe operation. And I think that's really been the push recently with the recent failures over the last couple of years. Is it's brought tailings into light and the spotlight, and so now we're seeing a much more focus and panel discussions like this on tailings management and TSF management. And I think that's really what's necessary to make sure that any type of raise type is operated successfully and the risk is reduced. Just for example, a cyclone sand dam is used quite commonly, where you're cycloning the coarse tailings and using that as the perimeter material, and depositing the overflow into the dam itself. And that certainly requires careful monitoring of what's being fed to those cyclones, and adjusting we've seen instances where operators are adjusting the grind size upstream to meet the specifications of the sand requirements. And so, as Todd touched on earlier, it's not. It used to be that the TSF got whatever it got, and you had to deal with it. And I think that's no longer the case. There's with this focus on proper tailings management, that we're getting more reliable TSF operation, more careful monitoring. And so I think the design of the TSF does play a role early on, but it doesn't necessarily exclude a particular raise type. It's a global perspective.
There's no doubt the type of construction affects the risk profile of the tailings dam. And just a quick primer on what types of tailings dams we're kind of talking about. You mentioned upstream. And what upstream tailings dam means is that you're placing your dam material on old tailings. That's the foundation for that next lift. Centerline dams use some virgin ground, but they also use some tailings as their foundation. So the virgin ground is obviously safer and more stable. And downstream dams just use virgin ground for their foundation. Unfortunately, as you go from upstream to centerline to downstream, the more virgin ground you use, the more material you need to construct the dam. So you need a lot more material for a downstream dam than you do an upstream dam. And that's the reason upstream dams are actually preferred in some cases, is the cost. And it all goes down to economics that we talked about before. And that because less material is needed, they're easier to construct, they're faster to construct, but they tend to be on potentially more unstable foundations. Now, to me, that means that you must have a much better monitoring program and a much better risk mitigation program if you're going to do an upstream dam. Personally, I'd like to see upstream dams not be allowed, but that isn't the case. So you definitely have to engineer them correctly, and you definitely have to monitor them well to make sure that there aren't issues. The other thing I would say about dam construction is that tailings facilities and dams are actually meant to be around in perpetuity. That means they're going to be around forever. So even if there's a small chance of failure, that means that they will fail at some point. And so when the dam is closed, if it's an upstream type of construction, they need to make sure that they've gotten rid of the water that's behind the dam so that there is a failure, or when there's a failure, that you won't actually have consequences downstream when there is that failure. And that's the issue actually they saw at Brumadinho, is they closed an upstream facility. It still had a lot of water associated with the tailings, and when there was a failure, it liquefied and the whole thing flowed down the valley and caused a lot of damage. So dam type and dam construction methods do play a role, I think, in terms of how they design and monitor their whole tailing system. And certainly at the end, they need to make sure they're getting rid of the water, because frankly, any type of dam structure probably will fail when you look at something, when you say it's in perpetuity.
I agree with what Todd said, and Matt as well. Essentially, if you are going to be building an upstream dam, you are building on the tailings, as Todd mentioned. So you need to actually understand really well what those tailings are going to behave, and like how are they going to react to the loading that are going to happen. If you do get water suddenly building up for whatever reason, what's the behavior going to be? So there needs in that case to be a lot more monitoring than what you would necessarily need to do with a downstream dam. One of the problems that we do have with downstream dams, though, is that sometimes when you're going to be doing your next lift, you actually can lose some of your instruments that you're using, or you can have some trouble actually trying to maintain those as you go up. So there's a lot of difficulty that can come with trying to actually follow a long-term monitoring, because you may have to either re-baseline or have a complicated analysis to try to bring everything back in line with each other. So there is complication with either way that you go. Personally, in terms of my experience, there's a lot of unknowns that come around tailings. Different sites will have different responses, and the tailings that they have, the chemistries are going to be a little bit different. And from my geology background and looking at quaternary type of sediments, the local processes that deposit, so the way that people design the deposition for whatever materials they have, all that's going to affect the stability of what's going on. So I would personally probably shy away a bit more from the upstream builds myself. But I spoke to another colleague of mine who had a lot of experience with upstream, and up until they came out, they were obviously they'd been working in more of a South African side, and for them, it wasn't until they left that they actually got more experience looking at centerline and downstream, and they swear by them. They think that it's a really good construction as long as you've done everything right. So I don't know that it's necessarily a case of let's get rid of any of the types, so much as if we're going to be using them, let's be sure and clear about our understanding, what we need to understand and how we need to monitor that. So using kind of an observational method potentially, and while we're building or backfilling, and having plans for what happens if a certain behavior is observed. So it's a little bit of a difference from your just standard monitoring where you'd have an exact, I want it to not move beyond X. Now you have to talk about having a plan of what you're going to do if you're going to see certain behaviors. So that becomes a bit more necessary if we're going to keep those upstream dams.
If I could just throw one more raised up into the mix, hybrid, if anybody wants to talk about just the technical aspects of that, how that works, and also something that comes up in the portal quite a bit, upstream then centerline or vice versa, or just a combination of two or more raise types. Would anybody like to just talk about the technical aspects of how that works and whether it has any specific, not consequences, but needs in terms of monitoring and mitigating risk?
So I don't have any experience in changing from an upstream to a center line or a center line to an upstream or a downstream type of dam, but I have been involved in quite a bit of discussions around how do you go to filtered tailings when you've got a slurry deposition. And there are a lot of things you need to be careful of there, because likely you're going to be using the same area that the slurry was deposited in now to deposit this filter cake that's been dewatered to a much higher extent, and trying to use some of the same infrastructure that you've had before. Unfortunately, placing higher density filter cake in a slurry area can be troublesome or problematic, and you certainly need to plan. They call it a mud wave. You start to put this higher density material in, you're going to start to push away the water and the slurry from where you're depositing it, and that's going to flow somewhere. So you need to make sure that when that material starts to have more stresses put on it and wants to flow, that you're able to control where those stresses go and where you're going to have that flow go towards. Obviously, you don't want that to go towards the crest of the dam, because then you'll have the issue that you're trying to avoid in terms of a dam failure. We've
discussed obviously active tailings facilities. I know a couple of you mentioned inactive. Certainly don't want to take away from the importance of that. And it is worth noting that inactive, closed, and even reclaimed tailings facilities in some cases can still pose a risk. According to the portal, 87% of TSFs have a long-term monitoring plan of some sort. 11% don't, 2% were unknown. What should such a plan include? What should a long-term monitoring plan include?
Generally, my experience has been mostly about trying to control the water levels and the chemistry of those waters. So it would have been things like making sure that you have good monitoring wells, good piezometer and things of that sort to measure and keep track of all that, the water pressures, and making sure that they're no higher than what you have planned for. Also things like looking for any cracking, any surface visuals that you could see, as well as your standard slope stabilities, making sure that nothing's happening to your structure itself. So obviously the base monitoring side of things. So trying to find a way to tie it all together is the key point there. And there have been more and more advances towards that kind of a centralized methodology where a lot of logger or visualization groups are actually working at trying to get as many types of instruments in. For example, even our affinity is a new thing that's coming out of RST. And in that case, they're trying to pull in some groundwater chemistry instruments that would actually be doing that monitoring directly. And you want to be able to one day, hopefully, be as open as possible so that people could actually see that kind of information in a logical way. You don't want it to be necessarily the here's my chemistry numbers, but maybe you want to have something that says, yep, we're still good. We're still within what we expected it to be. We're nowhere near a danger zone, and we're not into any alarming points. So having something like that planned out for the closed facilities so that the community at large can actually have a better feeling about what's going on, and having the tools to be able to do that would be really the ideal.
That would be something more and more we would see requests or demands for as well, for that transparency.
Yes.
Okay, and Matt?
Yeah, I mean, in terms of closure management plans, as Christiane mentioned, kind of regular active monitoring on the site, I think is essential in terms of monitoring these facilities. Certainly a water management plan in terms of surface water as well. You touched on groundwater. Certainly keeping surface water out of the facility as much as possible. As Todd mentioned, the Brumadinho failure was really driven by the excess water in that facility, even though it was closed. So keeping the water out of the facility, diverting it as possible. There's been quite a big advancement in satellite-based remote monitoring for ground deformation, where say once a month or once every couple of months, the satellite will fly over and can monitor for displacement. That's certainly quite an interesting technology that's being developed, and so that you really need to have this whole closure plan, and in addition is understanding what the risks are when it does fail. As Todd mentioned, these are around in perpetuity. What are the consequences of a failure, and can you mitigate that risk and reduce that risk? We've seen instances where old historical tailings facilities aren't, they haven't been designed to modern standards, whether it's groundwater seepage problems or stability problems or any number of problems. But we've seen operators where they've opted to take those historical facilities and either relocate them into a newer facility. Certainly that's a costly endeavor to do so. There's other operations that use their historical tailings that they'd like to clean up as backfill and put it back into the underground mine if it's under underground mine, while depositing the fresh tailings into a modern facility that has up-to-date design standards. So there's some ways to how can we reduce the risk of these closed facilities, and make sure that they're not prone to problems.
Yeah, I think Matt and Christiane hit it really well. Tailings need to be, when they're closed, geochemically and geotechnically stable. And both of those really mostly revolve around water management. They become geochemically unstable if you have PEG material that might produce acid mine drainage, and that requires water. If it becomes geotechnically unstable, that typically means you've got too much water inside of your dam, and it's the water acts like a lubricant and is potentially causing failure. So again, it comes back to management of the whole water system that's within your tailings facility, and I think Matt and Christiane both explained that pretty well. I think about the only thing I would add to that is you need to plan for your closure up front. Most mines do that already, but I think they're starting to do a much better job with that to understand what their closure plan looks like. And that closure plan may include higher levels of dewatering of the material, like we've talked about. One of the benefits you get with that is when you go to close a tailings facility, it usually means you put a cover on it, and it means you got to get rid of the slurry that's out there. So the less water you have to deal with on top of your tailings facility, the easier that closure is going to be. So filtered tailings is a lot easier to close than a slurry deposition. You can also look at the kinds of material that's in your tailings. For example, pyrite is something that is not valuable, but lots of times ends up in tailings facilities because it's associated a lot with copper and some of our other sulfur-bearing minerals. You can actually go through another process step to separate out that pyrite before it gets out to the tailings, because pyrite is an acid-generating material. And you can store that in a different place in a different manner and something that's much more controlled, so that your main whole TSF, tailings storage facility, isn't contaminated with that pyrite. So it's much easier to close that. And then you've got a special closure plan for the pyrite material that's contained somewhere else. So I think all of that planning going on up front, along with all the monitoring and water control that has been talked about, is something that miners are starting to do a lot more of, and I think is going to prove beneficial for everybody.
Before we finish up, would anybody like to share some parting thoughts?
This one's a little bit on the side, but it's similar. One more use of the old tailings, Matt made me actually think about this one. There's been actually some reuse of older tailings that hadn't been actually processed as well as they could have been. So we've actually been seeing people do that and then do the backfill afterwards in the same way that Matt had mentioned. And that by itself is actually an interesting impact if you think about it, because now you're going into a facility that would potentially have been previously closed, at least partially closed, or to that effect. It's an older facility, and you're coming in and disturbing it so that you can get something valuable out of it, and then you have to reclose. So there's all those aspects that also go into it. So you have to know where everything is. And if you plan to do something like that, potentially knowing that technology changes and knowing that demand is always increasing for these ores, then you can at least come in with a plan ahead of time. So much to Todd's point, when you do your closures, you kind of need to plan what you're going to do, so that before you even really start, because of the fact that it's going to give you that opportunity to decide where you're going to be putting certain aspects or certain pieces of it, so that you can do things like getting rid of your pyrite ahead of time. Especially nowadays, when we start hearing about interesting discoveries, like pyrite can be used for doing some new battery work that they've been talking about, that there's some ways of extracting that. So what was previously a useless piece of material and something that was waste is now potentially useful. So I think there's always an interesting thing about the fact that we're always changing, and what we think is closed is not necessarily going to be closed forever.
Yeah, I think there's a real opportunity there for us to reprocess some of these old slurry tailings. Some of the tailings grades of those old tailings facilities sometimes is bigger, more valuable than what the head grade is on new mines. Yeah. So not only is there copper in there, but as you say, maybe there's pyrite, something else that we can recover. And if you can show some profitability in reprocessing those tailings to pay for a better disposal method, everybody wins, right? You make some money. That money also pays for higher dewatering technologies, and you have something that's safer and can be much more stable into the future. So I think that's definitely an opportunity in a growing market.
Yeah, and I think, Todd touched on it just a bit ago. We want to make sure we're depositing and creating a geotechnically stable impoundment, and a lot of that pushes for dewatered and filtered tailings, but we don't want to trade the geotechnical stability with the geochemical stability if it is an acid generating material. And so, as always, it's very site specific and location specific, but we need to look at the whole life cycle of the tailings, from all the way up to the initial grind size through closure. And I think so often, you know, when you do the economic analysis of the tailings storage facility, the closure gets discounted so much because it's so far in the future that a lot of times it's not properly thought out, or it's thought out, but it's just too hard to quantify that far in the future. And I know there's been a lot of recent work on that of really understanding the true closure costs of these facilities and incorporating that into the initial design to help justify some of these higher dewatering technologies.
Jan, Todd, Matt, thanks for an informative discussion about risk mitigation and monitoring of tailings facilities. Thanks.